next presenter is Sébastien Buisson. He's been working on Lustre for 15 years. He initially lead solution and development activities for Bull, but in recent years focusing on Lustre development at DDN. He's a recognized expert in the area of Lustre security within the community and has presented various topics on this area at Lustre conferences over the years. He currently works in the Web Cloud engineering division at DDN and is based in Grenoble.
Thank you. Hi, everyone. So with this presentation, I wanted to give you an update on the latest news about the Lustre client encryption feature, and also show ongoing discussions about currently identified limitations and how they could be addressed. Before we start, I want to say that this presentation includes a quiz. So this is going to involve you in the room and also you online. This is a quiz that is hosted online. This is live and this is going to be competitive. So you will try to score as many points as you can. And maybe you can win free drink at tonight's dinner party. Depends on the luck organizers. Or maybe you could get self-satisfaction and pride. So this quiz is going to be hosted on the Kahoot platform. So maybe I will give you the login details later in this presentation, but maybe what you can try now is to have access to the kahoot.it website just to see if it works for you. So this is kahoot.it and not kahoot.com, so kahoot.it. And yeah, you can connect with your smartphone or your laptop. Either way works. Okay, so here's the outline for today. First, I'm going to explain what is exactly the Lustre client encryption feature and where we are with 2.15. And then the second part of the presentation will be dedicated to the currently identified limitations with the feature. So this is fit to pass and access to raw encrypted information mainly. And the purpose is to see how these limitations can be addressed. Okay. Let's get started. So you are probably already familiar with that. On kernel side, we do support the fscript library that is provided with Linux 5.4. And if you are using the other distributions that are mentioned here, so these are the main Linux distros out there, you're going to use the embedded llcrypt library that is included with the Lustre code. On user space, we rely on the fscript command line utility to decide which directories are encrypted and how they are encrypted. So in 2.15, we have support for content encryption and also name encryption. Since my luck talk back in May, we made a couple of enhancements to the Lustre client encryption feature. The first one is, so before that, it was already possible to use E2FS CK or debugfs on an LDiskFS target that is hosting encrypted files. And now we have improved the situation and we are escaping encrypted names so that you can even mount your LDiskFS target and browse it without breaking your shell. So that's useful when you need to have access to the device. We also recently reintroduced the null encryption mode for name encryption, and in 2.15 this is the new default. So it means that for newly created encrypted directories, by default the names of the files and directories will not be encrypted. Of course, you can decide to enable this feature. So there's a global tuning parameter. This is called enable file name encryption. And if you set that to 1, then the newly created directories will have names encrypted. So it only works for new encrypted directories. Another improvement is regarding compatibility between 2.15 and 2.14. So the 2.15 client is able to handle name encryption, but the 2.14 server does not understand that. So in order to avoid problems, there is now a connection flag So automatically, the 2.15 client is aware that it is talking to a 2.14 server. In this case, it is not using name encryption to avoid any problems. And the good news is that all these enhancements will be available with the 2.15.2 maintenance release that will be released later this year. Another recent enhancement is regarding performance with encryption. I already presented this performance optimization. It is targeting write bandwidth, and so it is using the, if you look at the internals, it is using the enc pool mechanism that is already here in Lustre for GSS support. And basically, this is a pool of page cache pages that are pre-allocated, and the pool can grow or shrink depending on usage. And we modified the LLcrypt library that is included in Lustre so that it takes its bound pages from this pre-allocated pool instead of being allocated every time it is needed. So we are saving a lot of page allocations. And thanks to that, we have pretty decent performance. Here you have the write bandwidth performance, and as soon as you are doing 1 megabyte IOs or larger, the performance drop is between 5 and 10%. And as I mentioned, this performance optimization only works if you are using the embedded LLcrypt library, but this is the default one when you build your Lustre client. And good news, again, this is going to be available in 2.15.2. Okay, so now this is the second part of the presentation. This is about the identified limitations with client-side encryption. The first limitation is fit-to-path. So basically, fit-to-path is a mechanism inside Lustre to map file identifiers to path names on the global namespace. So it's very convenient, and it's used in many tools that work on top of Lustre. Problem is, this feature doesn't work currently with encrypted files. Okay, so now it's time for you to work a little bit. Let's see. So if you want to play and join the quiz, you have to go to the kahoot.it platform and enter the PIN code that is at the top of the screen. For millennials, you can just scan the QR code at the top as well. And so you will be asked to enter sudo. And then when you have joined, we can start. So I'm sorry, this is limited to 50 participants, so please make sure you join now if you want to play. So I can see there are a lot of people joining. Thank you for that. I hope it will be fun. So you will have to find the right answer to questions, and you will have to answer as quickly as possible, because the quicker you are, the more points you score, and then you will win a free drink for tonight. So I will wait a little bit more. What else to say? No, it's just basically it's to test your knowledge of Lustre and common sense. Okay, so if you join, just one word. If you join using your smartphone, you may be disconnected once your screen gets locked. In this case, you just have to refresh the page, and it will be you will be connected again. Okay, I think we can start the quiz. You can join anytime, so don't worry. Okay. So first question. So according to you, where do you think name encryption and decryption is carried out? So is it carried out on Lustre client side? Is it carried out on Lustre server side? Is it carried out on both sides, or is it carried out outside of Lustre? Okay, time is out. The right answer was, of course, Lustre client side. Quick look at the current ranking. Okay, question number 2. Where is fit-to-path resolution carried out? Do you think fit-to-path resolution is carried out on Lustre client side, on Lustre server side, on both sides, or outside of Lustre. So, time is out. The correct answer was Lustre server side. We will do a debrief.
Is there a price
Okay.
if we are last? That's quite good right now.
I guess if you're last, maybe you will have a free registration for next year in order to improve your Lustre knowledge. No, I'm just kidding. Okay, question number 3, double points. This is a bonus question. Which key do you think is used to encrypt one file's name? Yes, this is a tough one. So is it the master key? Is it the per file key? Is it the parent key? Or is it the monkey? So the right answer was the parent key. So after 3 questions, this is quite close between Simon, Adrian, and Stéphane. Okay, so this is the end of the first part of the quiz, and now let's debrief. So, as the name suggests, Lustre client encryption is carried out on Lustre client side. It means that server side knows almost nothing about how to carry out encryption. On the contrary, feed-to-path is carried out on Lustre server side. It means that when you are doing LFS feed-to-path, the client sends the feed to the server, then the server builds the whole path and just returns a string to the client. And you have to know that when you have an encrypted directory with files and directories inside, all the encrypted names are encrypted with the same key, which is the parent key. So today, if you try LFS feed-to-path on an encrypted file, we made the choice to return INO data because the Lustre client code cannot understand raw encrypted data that the server would return in the current status of the code. But of course, we would like to address this limitation. And our proposal is to let the server return the raw encrypted information that has been built with all the path components on server side, but to encode that. And then the first thing that the client would have to do would be to, so I'm talking about the LFS feed-to-path command, it would have to parse the string that is received from server, so that would look like this example here. The encoding we use guarantees that there is no slash or null characters inside the individual components. And so the client would have to recursively call from top to bottom do the following. So first, decrypt the name, and if it's a directory, do a lookup on this name in order to retrieve the inode, and this inode is giving us access to the encryption key, and so recursively you call that from top to bottom in order to decrypt the whole path. So it means that with a normal file, you have a single RPC operation, and for encrypted files, it would be turned into multiple lookup operation. So this is going to be much more expensive for encrypted files if the name encryption feature is enabled. Okay, so let's move on. Let's talk about the other identified limitation with client encryption, which is access to raw encrypted information. For different purposes, we might want to be able to open encrypted files if we do not have the encryption key. We also might want to read or write encrypted files without the encryption key, or even get access to the encryption context and the raw encrypted name. But all these accesses are forbidden by the FSCrypt library. And this is some kind of limitation for us. So let me get back to the quiz. So I will let you reconnect. So if you are on your phone, please make sure that you've refreshed the page. In the following question, there might be several possible answers, several possible correct answers for the same question. So don't be surprised. Let me wait a little bit more for people to rejoin. Okay, so question number 4. What are the use cases for access to raw encrypted information? Maybe that would be useful if you want and need to move encrypted files between different file systems and without the need to decrypt and then re-encrypt stuff every time. Maybe it's useful for backup restore or Lustre HSM or just hack to metrics just for fun. So there are 3 correct answers to this question. Okay. Oh, Stefan. Question number 5. What are the security risks of exposing raw encrypted information? First risk would be to be hacked by Neo from the matrix. Another risk would be to leak precious information. Maybe it would give the ability to corrupt files, or maybe there is no real security risks in doing so. And the correct answer is there is no security risk in exposing raw information. That was a tough question, I realize. Okay. Question number 6. This is, again, a bonus question, double points. What are the security risks of backing up encrypted files in clear text? So maybe you could be hacked by Kevin at 12. Maybe you could be exposing private information by doing so. Maybe it's a problem to make clear text copies. Or maybe there is no security risk in making clear text copies. And again, there were 3 possible answers for this question. Okay. So after 6 questions, let's have a look at the current ranking. Okay. I cannot see the others, but keep up the good work. There are 3 more questions to come. So first, let's debrief that. So we have identified 3 main use cases that would require having access to raw encrypted information. The first one is, let's imagine you have a cloud infrastructure with your data, and then you have a scratch file system, and you have encrypted files that you need to move to your scratch file system in order to do some computation. And in this case, you might want to avoid as much as possible reading the files, which means decrypting them and then rewriting them, which means re-encrypting. So that would be smoother to be able to copy those files without the need to decrypt and then re-encrypt. The other main and obvious, let's say, use case is to be able to back up and restore encrypted files without the encryption key. It's important to do that without the encryption key because these are encrypted files, so we definitely don't want to make clear text copies of those files. And the same goes for Lustre HSM. We might want to use Lustre HSM with encrypted files on the Lustre file system, but again, without the encryption key to prevent making clear text copies on the cold storage. Problem is for FSCrypt forbids all that kind of accesses. But the thing is, there are no security risks if we have access to raw encrypted information. Raw encrypted information is useless without the key. This is the reason why we encrypt, right? If you have an encrypted flash drive and you drop it in the street, well, you've lost your drive, but nobody is able to read what you put on that drive. And the same goes here. Obviously, you might not want to store your master key along with the encrypted files that you've backed up. So that's common sense. The encryption context in itself does not contain any valuable information. It contains 16-byte nonce that is used in combination with the master key to derive the per file key. So once you have derived this per file key, you can have access to the clear text content. But again, if you're not storing the master key along with the encryption context, there is no security issue. The only risk, but it's not a security risk, the only risk is to corrupt your encrypted files when you write to them without the encryption key. If you write some bytes in the file, it might end up, you might end up getting garbage when trying to reread this page. But this is the only user error that we can identify here. Okay, so this is the last part of the quiz. 3 remaining questions. So I will let you join or reconnect. Okay. So question number 7. Do you think it is possible to revert back to raw encrypted name from presented name? So imagine that you are accessing and listing files without the encryption key on your Lustre file system. And do you think it's possible that the presented name can be used to revert back to the re-encrypted name? Always, never, maybe it depends on the name length, or maybe it depends on the bytes that are in the names. And so the right answer is it depends on the name length. So we will get back to that just later. Okay. Oh. No points were scored by the leaders. Wake up, guys. Question number 8. Where is stored the size of an encrypted file? So do you think we are using a specific extended attribute on MDT object? Do you think we are using a specific extended attribute on OST objects? Maybe we repurpose the LSOM extended attribute, or maybe we just store size as with normal unencrypted files. And the correct answer is we just use the same mechanism as with normal Lustre files. Okay. Last question of the quiz. Again, bonus question, so double points. Do you think there is any difference between the encrypted file size seen with and without the encryption key? So imagine that you are starting a file with the key, you see a size, you are starting the same file without the encryption key. Do you see a different file size or not? Maybe it's rounded up to 4K, or maybe it's just the same size you can see. Wow, that's a split. And the right answer was it's rounded up to 4 kilobytes. Okay, so let's debrief these last questions. So first question was about the raw encrypted name. When you browse your encrypted directories without the encryption key, you see scrambled names. And those names, for short names, these are the raw encrypted names that are just base 64 encoded. So in this case, you can consider that you would be able to revert back to the encrypted name. But for longer names, it's actually a digested form that contains only a portion of the raw encrypted name. So this is to say we cannot count on the presented name without the encryption key to think that we will be always able to get the raw encrypted name. Also, without the key, when you browse your encrypted directories, the file sizes are rounded up to the next encryption boundary. So in the quiz, I said 4 kilobytes because the encryption unit size we use is 4 kilobytes. And we are doing this roundup. And for instance, if you read the file without the encryption key, it will let you have access to the whole pages that are encrypted and not just the bunch of it, a part of it. But still, we need to keep track of the clear text file size. It cannot be inferred from the raw encrypted content because raw encrypted content is full encrypted blocks. And this clear text file size must be restored, must be set back to the files when we restore them. Last comment is about the encryption context. Obviously, we need to save this encryption context if we want to have later access to the clear text content and name. So what we propose to address this limitation is to present a virtual new extended attribute specific to Lustre that we would call security.encdata. And this extended attribute would contain all the information we need for the different scenarios I was describing earlier. So that would contain the clear text file size, the encryption context, and the raw encrypted name. For backup and restore, we would have to modify the tar utility. And for Lustre HSM, we would have to modify the POSIX copy tool, simply because in case those tools are dealing with an encrypted file, they would have to explicitly fetch this extended attribute. We do not want to expose this extended attribute when, for instance, you list all the existing extended attributes. And the other thing is that those tools would always need to use specific open flags, because we do not want any application to be able to open encrypted files without the encryption key. You have to set specific flags explicitly so that you're allowed by Lustre to read and write content in the file without the encryption key. So as a conclusion, we can say that Lustre 2.15.2 has full encryption support, content encryption and name encryption, with a pretty good performance level. We have identified limitations with the feature. That was just a sneak peek at what we want to do. There are ongoing discussions with the other Lustre developers in the community to find the best solution possible in order to address those limitations. So this is really the early stage and the design stage that is happening now. And that's all for this presentation. I hope you enjoyed it. I hope you enjoyed the quiz as much as I enjoyed preparing that. So I think this is the time to have a look at the final ranking and see who won a free drink for tonight. So in number 3, we have Seb Pichowski. Congratulations. Number 2, Simon. Who is Simon? And number 1, this is Guillaume. Okay, and in number 4, we have Stefan, and I could not see the number 5, but congratulations, and thank you for participating, and I hope you enjoyed and to have something more interactive than we have usually. Do you have any questions?
Thank you, Sébastien.
Sure.
Any questions?
Just curious about these performance penalties for the encryption stuff. Are there ways to mitigate the performance as a more metadata servers, more OSS servers, or stronger compute nodes, or what? How to mitigate it?
It's really, so the performances are really bound to the compute power on the client. Well, it's really bound to the client, so compute power and extra operations that need to be carried out because we are handling encrypted files. So if you look at the performance graph here, you can see that without the performance optimization, the performance drop was more like 20%. Obviously, we are doing more work when we need to encrypt or decrypt files. And as this optimization suggests, the main pain point was allocating pages to carry out encryption. So this is how we managed to reduce it to an acceptable level. So here you have the performance with for write bandwidth, sorry, and maybe I have some backup slides. Yeah, here you have the read bandwidth performance, and as you can see, the performance drop is around 5%, so which is pretty nice. And here you have metadata performance. So again, a pretty reasonable performance impact to have names encrypted.
Yeah, it's important to note that this is the performance limitation is only, that's a single client performance. And if you
Sure.
have any kind of bandwidth limitation on the network or the servers, then there's no overhead at all. Because if the clients are, doing the encryption faster than the servers can process the data, then there's no overhead on the servers from the encryption. It's just raw data to them. And so there's no overhead at all in that case.
We can say that these performance numbers are for worst-case scenarios where this is really a single client that is limiting the overall bandwidth, but it rarely happens on production clusters daily.
Any other question? I have one, Sébastien, about CPU performance. Have you got measure the CPU resources impact with encryption and without encryption? It's cool to have numbers on throughput, but about CPU resources, have you got a number?
Yeah, of course. When you do encryption, you're worried that your CPU power is used not for computation, but for encryption. So I haven't numbers here, but really the performance after this optimization, the performance number impact was more because of the the extra operations that are being carried out in Lustre. So CPU usage was not like 80% or something. No, it was pretty reasonable. But I'm sorry, I do not have exact numbers. But it's not huge. And this API, the FScript API provided by the kernel and that we embedded in Lustre, uses AES algorithms. So most modern CPUs, Intel CPUs, have hardware acceleration for this. So this is not a big deal.
Cool, thank you. Any other question? Perhaps online? Okay, thank you again, Sébastien.